Hi everyone, welcome to the zip slip case. It's a scary story. I'm Xavier, I'm working for Semmle, and our first chapter will be about a critical bug, a scary bug that was spread in many code bases. What's this bug? Let's have a look at the code. We are trying to extract an archive into our file system in a given destination directory. But if you look on line 5, you can see that path.combine will just concatenate the destination directory with the entry path. OK, so, and then afterwards, we just write this to our file system at this location. Imagine that an attacker can forge a malicious archive with different paths with dot dot slash dot dot slash dot dot, with several levels of dot dot. Then they can hope that one of these malicious paths makes its way to the proper destination directory, like your root directory, where it can cause a catastrophe. So back in April, this vulnerability was discovered by Snake. Snake is a company that provides automatic finding of problems, vulnerabilities in your dependencies. So quite a malicious bug, quite a critical bug, and of course, a lot of people took it very, very seriously, and then the hunt began. So what's the cure for this problem? So instead of taking directly the result of path.combine, then you can get the full path. Get full path will resolve the dot, 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 dot. Then afterwards, you check that the destination file is included into your expected destination directory and not somewhere else. If not, then you stop and you throw an exception. Fairly easy fix. So Snake worked with many project maintainers to fix these occurrences of the pattern because it was spread amongst many code bases. Okay, so they made a very good work, and fixed versions of all these libraries have been provided by the maintainers. And of course, vulnerable versions were tracked and reported in software like Snake. But this is a very artisanal process, right? The effort needed to find this pattern is repeated for each library, for each code base. In some cases, maintainers were claiming that the bug is not exploitable in their case because somehow between the archive full path and the place where it was actually written into the file system, there was some sanitation. And most importantly, the problem is how can we make sure that the bug won't come back in a future version of the library? So this is where our hero crafted a magic weapon. As we're all grown-ups, we know that there is no such thing as a magic weapon. And we're all software developers, and we know that the only weapon we have is code. So what happened is that we coded the weapon. So with Semmle QL technology, you extract your code as data, and then you can search it. You can search through this data thanks to an object-oriented language. So what happened is that in August, Dennis Levin, software developer at Microsoft, he decided to code a QL query to find all variants of this problem in the entire Microsoft C# code base. To do this, he used our data flow library, our native data flow library. We have a taint tracking feature which will taint all data flowing from one source to one sink. So if you look on the right-hand side at what the query looks like, then you see that it's like an SQL query, but with a language, from, where, select, and zip taint tracking has flow will give you true if the data flows from this source to this sink. But in more detail, what happens is that Dennis extended our native data flow library to match it to the specific zip slip case. How to do that? He extended the node flow, the data flow node, with a source, a sink, which are relevant for the zip slip case. So basically, a source would be any variable that holds the full name of an archive entry. This is the source of the problem. And a sink would be any relevant parameter of a function that would be used as the destination path to write a file. And then you remember that there were people who were claiming that the bug was not exploitable in the case because they had sanitizing functions on this path. Then yes, you can also extend the sanitizers to declare functions that would validate the variable with respect to the destination directory, or would search for ... inside this name. And then when you extend the source, sink, and nodes, then you can call the hasFlow function that will return true if a data can actually flow from this source to this sink without going through any sanitizer. Let's have a closer look at what it means. So this is the code that Dennis wrote, because our queries are open source. You can find them on github.com/Semmle. So for example here, how do we define the source? I define the source as a property access where the name of this property is full name, and the data that it's accessed from is a zip archive entry. Okay, that's really the source of the zip slip vulnerability pattern. Let's see how to define a sink. So one thing can be, if I'm an argument called destination file name of a call to a method extract to file, then yes, I'm one potential sink for this vulnerability. Another example, is I'm the argument called path of a call to a method create or open write or open, then I'm a potential sink for the zip slip vulnerability. Last, let's see, and of course you can define several sinks according to their relevance with respect to this vulnerability. And then sanitizer. So for example here, it says, okay, if I'm a method call substring, then I can suppose that, yes, I'm trying to extract some components from this data, so I'm sanitizing it. So this should be excluded. Okay? So when Dennis has defined all these source, sink, and sanitizer, then you'll have at the end, hasFlow will get you any path where you have data coming from this kind of source, going to this kind of sink without passing through this sanitizer. And it does the magic. So basically, Dennis coded the pattern. He coded variants of the pattern. As we've seen, he has coded different sinks because you can have different potential sinks for this problem. And he has coded also these exceptions, the sanitizers. All of them are coded in the query. So it's repeatable. It can be used on different code bases without pain. You can improve it by adding additional sources, additional sinks, and additional exceptions, so making the query more and more accurate. And as we've seen, it can follow complex control flows because it's based on our native data flow library. And the query is integrated into LGTM. And you can see on the right-hand side that as it's integrated into LGTM, you can activate automated code review, and this query will be run on all your pull requests, preventing such a bug from reappearing again in the future. So that's it. He found a lot of occurrences of the vulnerability into Microsoft code, and he was very happy with it. But the story doesn't end here, because Dennis decided to share this solution with the entire community. Our queries are open source, so Dennis made a pull request to include this zip slip vulnerability query into the Semmle's repository. So a few days later, the pull request has been accepted. The query was available to the entire open source community. So the query is now available to all of you. And let's have a look. If we have a look here, then we see that there are several open source projects with occurrences of this query. For example, here, path.combine, and then right after it, extract to file. So the problem is still here, and thanks to the work of one developer, it can be used and shared by the entire development community. And of course, there have been people who, aware of this, thanks to LGTM and aware of the alert, have fixed this query, for example, here, by applying the recommended solution, which is to get the full path, resolve the ... and then check if we're in the expected destination directory. So yes, this is almost true, because this query exists only at the moment for C# language. So there might be other occurrences of the problem sleeping out here in Java, C++, etc. projects in the open source. And well, they are just waiting for you to contribute with a query for these languages. And of course, it's only available for projects that are analyzed by LGTM. So I can only tell you to add your project now. It's free for open source public repositories. So if your project is on github.com, it's a one-click button. You can add your project and benefit from this query. So as a conclusion, thanks to QL, so the query language, and LGTM, which is the front end that will enable automated code review with these queries, you can code your vulnerability hunt and repeatedly find variants of the bug, prevent future occurrences by integrated automated code review in pull request, and you can, of course, share your work with the development community. Vice versa, because others will share their work with you, then you will benefit from the work of all the bug hunters. And amongst our clients are Microsoft, Google, NASA, so all these guys with great security research team, you will just benefit from the work that they are doing. So basically, the development community is your security team. So Semmle's variant analysis, because it allows you to find variants of vulnerabilities in your code. This is the sustainable solution to discover bugs, to discover their variants across all code bases, and to prevent them from reappearing in the future. Basically, with this solution, we are moving vulnerability hunting from medieval times to press printing times. Thank you very much. We're up here, so come and visit us. This is the booth with the jungle and the fog, and we will be very happy to show you some demos. Thank you.